Hey there! This video is about using the same cooling coil to cool the water to both the counterflow chiller and the Grainfather conical fermenter. Now, if you live in an area where the city water is cold enough to cool your wort down to pitching temperature, then you're probably not using a cooling coil. And if you're able to place the Grainfather conical fermenter into a temperature-controlled location, then you don't need to recirculate cool water through the fermenter's internal cooling sleeve. But for the rest of us, who rely on a cooling coil to cool the water going to both the counterflow chiller and the Grainfather conical fermenter, and for those of us that don't have the money to buy a glycol chiller, this video is for you. Next, I'll go through a list of the equipment being used in this video. And in the interest of time, I won't go through a description of each piece of equipment or the modifications that I did or the recommendations based on lessons learned. Instead, in the description section of this video, I'll include a list of the equipment, links to where you can buy the equipment, and links to the award-winning equipment videos in my YouTube channel. I made that last part up. So, are you ready? Well then stop your grinning and drop your linen. So, here's the equipment that I use on brew day. I use a Grainfather boiler G30 to brew my wort, and a Grainfather sparge water heater to gravity feed hot water into the grain basket of the G30 when the grain basket is up and in the drain position. I have a small ice machine in my home brewery, and prior to brew day, I bag around 5 bags of ice and store them in the freezer. On brew day, I use the bags of ice to keep the cooling coils covered in ice, and the cold water coming out of the coils goes into my counterflow chiller from Northern Brewer to cool the boiling wort down to pitching temperature. The wort coming out of the counterflow chiller is filtered through a bouncer ND to remove any sediment, and then into the Grainfather conical fermenter. Now, I monitor the temperature of the wort using my Blickman thermometer and control the temperature of the wort by restricting the flow of hot wort being pumped from my G30 into the counterflow chiller. Conversely, I control the temperature of the cold water coming out of the cooler and into the counterflow chiller by regulating the flow of water going through the cooling coils. After I fill my Grainfather conical fermenter with wort and I pitch the yeast, I rotate the 3-way control valve selector knobs to the fermenter position, which circulates the cold water through the same cooling coils and into the Grainfather conical fermenter's cooling sleeve in a closed-loop system. Now, once a day, I'll add ice directly from the ice machine's holding bin into the cooler, which amounts to about a half a bag of ice every 24 hours. Next up, I'll show you the different versions of the dual-purpose cooling coil system that I built over the years. Oh yeah! Now, over the years I've built 3 different versions of the dual-purpose cooling coil system, and each time I made improvements to my design. Version 1 was a cooler within a cooler concept using PVC board from my local home improvement store and an old plastic storage bin. I built a small cooler out of PVC board for the cooling coil, and I installed it inside the plastic storage bin. I installed a drain at the bottom of the plastic storage bin and surrounded the bin with spray foam insulation and 1/2-inch PVC board. The small cooler confined the ice and cold water around the 50-foot coil, and an overflow pipe drained any excess water out of the small cooler into the plastic storage bin and then out the drain on the bottom. I used a combination of CPVC and PEX piping to feed the cooled water to either the counterflow chiller or the Grainfather conical fermenter through a couple of 3-way valves. I also installed a bleed air valve to remove any air bubbles in the line, which could make the Grainfather conical fermenter's pump cavitate. Version 1 worked fine for years, and I kept a list of all the improvements I would make if I ever built version 2. So next up, version 2. For version 2, I decided to use an existing portable cooler we had lying around. By the way, I recommend notifying your wife before you start drilling holes in the family cooler. In my defense, I decided to double the length of the cooling coil by connecting 2 50-foot coils together. Therefore, I needed a bigger cooler. For version 2, I was able to reuse the front panel of the PVC enclosure from version 1, which had the 2 3-way valves and bleed air valve already installed. I drilled a hole in the cooler just above the cooling coils and installed an overflow drain pipe. Now, because the cooler's drain plug was on the right-hand side instead of on the left-hand side where I needed it, I drilled another hole in the cooler just above the water line and installed a fish tank pump at the bottom of the cooler to drain the water after the fermentation was complete. I installed the Grainfather conical fermenter water circulation pump in a location so that I could view the input hose for any air bubbles, and I made sure I had easy access to the pump in case I needed to replace it. Using our family cooler worked out well. For me. It kept my ice cold for 24 hours and it was large enough for the 100-foot cooling coil inside. However, I had problems sealing the gap between the top of the PVC enclosure and the sides of the cooler due to the contour variations around the cooler's hinges and around the sides. Again, I kept a list of potential design improvements I would make in the event I decided to build version 3. So, what's up next? You guessed it, version 3. Don't touch that dial. So, each three-way valve has a common connection point, which is channeled to one of the other two connection points of the valve, depending on the position of the selector knob. The common element of this system is the cooling coil, so again, depending on the position of the selector knobs, the three-way valves will connect the cooling coil to either the water supply and counterflow chiller, or the fermenter's input and output connections. It's always a good design practice to lay out the plumbing to the valves so that both the selector knobs are facing in the same direction for either the counterflow chiller or the fermenter. Using the dual-purpose cooling coil for the counterflow chiller requires the selector knobs to be facing in the counterflow chiller position. Water coming from the water supply goes through the three-way valve and up into the input of the cooling coil. The cooled water comes out of the coil and goes to a T-junction to the thermometer and the other three-way valve. The cooled water is channeled through the valve to the counterflow chiller and then out the drain. Now, before I rotate both selector knobs to the fermenter position, I want to make sure there's no air bubbles in the system. I keep the valve selector knob on the valve connected to the water supply in the counterflow chiller position, and I rotate the selector knob on the other valve to the fermenter position. This is the only time the selector knobs will be facing in the opposite directions. With the power off to the fermenter's controller, the water circulation pump will freewheel as water passes through the pump. Water coming from the water supply goes through the valve, through the cooling coil, the other valve, the pump, and through the fermenter's internal cooling sleeve. The water is blocked from going back into the valve due to the position of the selector knob, and instead passes through the open bleed air valve into the counterflow chiller and then out the drain. I observe the water going through the bleed air valve and the water coming out of the counterflow chiller to see if there's any air bubbles. When the water is running clear, I shut off the water supply, close the bleed air valve, and then rotate the other three-way valve to the fermenter position in order to establish a closed loop system. When the valve selector knobs are facing in the fermenter position, the cooling coil is connected to the fermenter's internal cooling sleeve and external plumbing in a closed loop system. When power is applied to the Grainfather fermenter's controller, an electrical input will be sent to the water circulation pump when the temperature inside the fermenter is above the temperature setting on the controller. So, the fermenter's controller activates the water circulation pump. Water is pumped through the fermenter, the three-way valve, through the cooling coil, to the thermometer, into the other three-way valve, and back to the pump. Next, I'll go through some recommendations based on lessons learned designing and building the dual-purpose cooling coil system. So, are you ready? Well, get your notepad because there may be a pop quiz later. All right, let's get started. The first thing to do is to buy a cooler. I don't advise building your own cooler because even though it's fun to work on, it gets expensive and quite frankly, it's cheaper just to go out and buy a cooler. Also, don't buy an expensive, well-insulated cooler because you're going to insulate around it anyway. The size of the cooler depends on the number of cooling coils you're going to install. A 50-foot coil works out fine. A 100-foot coil works out even better. However, This means that the cooler will need to be larger. Buy a cooler with flat sides because it's much easier to work with and it minimizes the gaps around the top of the PVC enclosure. Buy a cooler with a drain, but make sure that the drain is located on the side that you want. As an option, you can buy a cooler with a blank location for a drain and then install the drain yourself. For version 3, I use PEX tubing for all the plumbing rather than a combination of CPVC and PEX. PEX is more expensive, but it's much easier to lay out the piping before crimping the fittings. PEX is easier to cut, less messy, and it won't leak if the rings are properly crimped. Put the PEX pieces together temporarily to determine the optimum lengths and layout. Always plan ahead as to how the crimping tool will be positioned, and whenever possible, externally crimp the fittings to avoid having to use the tool in a tight spot. Also, it's less expensive to buy bulk quantities of fittings on Amazon rather than buying them from your local home improvement store. Next, I built an insulated base for the cooler to sit on and an insulated enclosure around the cooler. I used non-expanding spray foam on the base, and I recommend using foam insulation board around the sides because it's easier to cut and attach to the cooler using 3M aluminum tape. The enclosure will contain all the plumbing plus the Grainfather conical fermenter's recirculation pump. I left 3 to 4 inches between the sides of the cooler and the enclosure for the plumbing and the insulation. I used 1/2 inch PVC board for the sides and a 1/4 inch PVC board for the top. I recommend using a cardboard template before cutting the top of the enclosure to avoid making costly mistakes. As a side note, if you build the enclosure in the corner of the room, it will minimize the amount of PVC board you'll need, which will lower the cost. The front panel of the enclosure is where I mounted the 2 3-way valves, a thermometer, a bleed air valve, and a threaded output fitting to attach the water input hose to the counterflow chiller. For version 3, I used the principle of hydrostatic equilibrium for the overflow drain instead of drilling another hole in the cooler for the overflow pipe. Make sure you test the correct height of the plumbing beforehand to determine the desired water level inside the cooler. As a side note, insert the output of the overflow pipe into a drain pipe that is above the cooler's drain port to prevent a continuous siphon of the water from inside the cooler. I installed a shutoff valve in line with the cooler's drain port to drain the water inside the cooler after the fermentation is complete and the beer has been pressure transferred from the Grainfather conical fermenter to a keg inside my kegerator. Inside the cooler, I used swivel brass fittings on the cooling coil input and output attachment points. This will allow for easy removal of the coils to clean inside the cooler. I also used swivel brass fittings with a 90-degree elbow to connect the 3-way valves to the outside panel of the PVC enclosure. The threaded fittings will allow easy replacement of a valve in the event it breaks, and the 90-degree elbows keep the valves close to the surface of the front panel. Always design for maintainability and locate all the plumbing connections such as the cooling coil's input and output, the water supply input, the drain output, the fermenter's recirculation input and output, and the Grainfather recirculation pump on the common side of the enclosure for easy access. As a side note, Grainfather doesn't sell the recirculation pump separately. However, you can buy one on Amazon for about $11 and keep one on hand as a spare. I installed a thermometer so that I can monitor the temperature of the water coming out of the cooling coil and going into either the counterflow chiller or the fermenter. I installed the thermometer stem into a PEX pipe with a T-fitting at the end so that the tip of the stem is at the 90-degree turn inside the T-fitting. Before installing the thermometer, I recommend inserting the thermometer stem into a glass of cold water and using a separate digital thermometer. Compare the two temperatures and use the screw in the back of the thermometer to rotate the faceplate to the proper setting. Located the 3-way valves on the front panel of the enclosure so the plumbing connected on the inside of the enclosure won't interfere with each other. This is where temporarily laying out the PEX piping beforehand will avoid costly mistakes. I installed an external output fitting on the enclosure's front panel, which is connected to the output of the 3-way valve inside the enclosure. The threaded male fitting attaches to a hose to the counterflow chiller using a female threaded swivel fitting. I recommend installing a foam insulation sleeve around the counterflow chiller water input hose to minimize any cooling loss. Lastly, I installed a normally closed two-position bleed air valve with a sight hose to observe any air trapped in the fermenter's recirculation system. As I explained earlier, the bleed air valve is at the end of the recirculation loop, and when the bleed air valve is open, it diverts the water and any air bubbles into the counterflow chiller and out the drain. Well, that's it. Have fun building your own dual-purpose cooling coil system, and as always, if you have any comments or questions, let me know. Cheers!